We're going to talk about dilations. We've talked about dilations in the pretty recent past, but we're going to do just a bit more with them. So we're going to be able to draw dilations in a plane and a coordinate plane, and we need to define dilation. So let's do that first. All right, on page, actually I pulled a lot of this from page 505. A dilation is a transformation that enlarges or reduces the original figure proportionally. So unlike all the other transformations we've done, this one is not considered a rigid motion. It's not a congruence transformation. It's a similarity transformation. All right? There is a center of dilation. Most of the ones that we're going to do, the center of dilation will be the origin of the coordinate plane. Okay? Now, we're familiar with scale factors. With similar figures, the scale factor is the ratio of a pair of corresponding sides. Usually the scale factor is written in simplest terms. So instead of 4 to 6, we would usually say 2 to 3. Okay? That's the ratio of a pair of corresponding sides. That scale factor is also the ratio of the distances of corresponding points from the center of dilation. For instance, point A and point J are corresponding points there. A is our original figure, or ABC is our original figure, JKL is our image of it. All right? So whatever the scale factor is for, let's say, JK to AB, that same scale factor gives us the distance from J to not J to A, from J to O, to the distance from A to O. Okay? Since the scale factor, if we'd never talked about dilations, and we just talked about similar figures, the scale factor is 3 to 2. The distance from J to the center of dilation, 2 over the distance Okay, sorry for the interruption. So if the scale factor is 3 to 2, then the ratio of the distance from J to the center of dilation to the distance from A to the center of dilation is also 3 to 2. Okay? So the scale factor tells us two things now. It tells us the ratio of pairs of corresponding sides, just like it always has, and now it also tells us the ratio of the distances of corresponding points from the center of dilation. You with me? Now, the numbers won't work. It's off scale, but tell me what this would be. If the distance from J to O was 6, what would the distance from A to O be? If that's the scale factor, it'd be 4, wouldn't it? Okay? See what I'm talking about? Y'all don't see what I'm talking about. Let's try this again. JK to AB is a ratio of a pair of corresponding sides. That's the scale factor. JO is the distance from J to the center of dilation. AO is the distance from A to the center of dilation. It equals the same thing. Okay? So, we make up different numbers. If the scale factor is 5 to 3, if the distance from J to O is 10, what's the distance from A to O? 6, so that you would have the same ratio. Does it make sense? All right. Now, like we've talked about before, the scale factor is new over old. Okay, so make sure you write it in that way, new over old. An enlargement means the new figure is larger than the original figure. A reduction means the new figure is smaller than the original figure. If the scale factor is greater than 1, it'll be an enlargement. If it's an enlargement, the scale factor will be greater than 1. If the scale factor is between 0 and 1, like before, I don't really want to talk about negative scale factors. All that does is flip the new figure to the opposite side of the center of dilation. So if the scale factor is between 0 and 1, it's a reduction. If the dilation is a reduction, the scale factor will be between 0 and 1. If you happen to have a scale factor of 1, then it's neither an enlargement or a reduction, and it's not really a dilation anymore, is it? Okay? All right. Let's do number 2 together from page 663. All right, so you don't need this one on graph paper. You just need a piece of paper. And use your straight edge to make a four-sided figure that looks somewhat like this one. They tell us that point M is the center of dilation. Okay? Here's what we do. Take your straight edge, and we're going to make a dotted line. From the center of dilation through point A, and keep going. A prime will be somewhere on this dotted line. Here's how we figure out where it is. The scale factor is 2. Now, if the scale factor is 2, that's 2 to 1. So usually we see it as a fraction, but 2's good. That means that A prime will be 2 times farther away from the center of dilation than A is. So whatever the distance from A to the center equals, multiply that by 2, and that's the distance from A prime to the center. Now, when the scale factor is a whole number like this, it's pretty easy to use our compass as our measuring instrument. When it's a fraction, it gets complicated. But this one's not a fraction. So we put actually, if I put the point of the compass there, all right, so I'll put the point of the, it doesn't matter. Measure the distance between A and M with your compass. And this is, we want A prime to be twice as far away. Measure that same distance to the other side of point A, and that's where A prime goes. So the point where the arc crosses the dotted line is A prime. Then we make another dotted line from the center through point B. We use our compass to measure the distance from B to the center. B prime is supposed to be 2 times farther away. Just measure that same distance to the other side of B. And that's where B prime goes. And I'll bet you know what to do next, don't you?
Yes.
There we go. Okay. So I'll measure the distance from C to the center. Go the same distance away on the other side. That's where C prime goes. Now, M also is part of this figure, but since M is the center of dilation, where do you think M prime is? The same point. Just like if a point's on the line of reflection, it doesn't go anywhere. Same thing's happening here, okay? Since M is the center of dilation, M prime is the same point. Then we use our straight edge. And there's our dilated figure. Since the scale, since the scale factor is 2, that means the ratio of the length of A prime B prime to the length of AB is 2. The ratio of the length of B prime C prime to BC is 2. So for instance, if I knew that the length of C prime prime is 5, wouldn't that mean that the length from C to M would have to be 2.5? Okay? All right. Questions?
Would your dilation change if K equals something else?
Yeah. For instance, and whole numbers are a lot easier to do using a compass as our measurement instrument. For instance, if the scale factor had been 3, if that was the case, when I measured, I'll just do this. When I measured the distance here from M to C, then I measure from C there, that's now I've done it. I've made C prime 2 times farther away than C. If the scale factor was 3, guess what I'd do? I'd move down here, and then that's where C prime would have gone. You following me? Okay. All right. Now, most of the dilations we're going to do are going to be in a coordinate plane, and we'll get to those in just a second. All right. On this one, this is from the Check Your Progress, back on page 662. It says, determine whether the dilation from Q to Q prime is an enlargement or a reduction. Well, is Q prime bigger or smaller? It's bigger, so that would be an enlargement. Then find the scale factor. Okay? The scale factor. We can find the scale factor one of 2 ways. Either make it the ratio of a pair of corresponding side lengths, or make it the ratio of the distance from the center to a point of the new figure, 15, to the distance from the center to the corresponding point of the original figure, which would be 5. See? The distance from C to Q prime is 15. The distance from C to Q is 5. So the scale factor is 15 to 5. But we'd rather simplify that if we can. So the scale factor is 3. Then they ask us a really tough question. They said find the scale factor and X. So if that's 15 and that's 5, what's X have to equal? Okay? Any questions? All right. Do this one. This one's part of your assignment. Number 3 on page 663. The same thing we just did in that example. Determine whether the dilation from B to B prime is an enlargement or a reduction. Find the scale factor. Find X. Enlargement or reduction? Yeah, it's definitely an enlargement. What's the scale factor? Yeah, scale factor is 4 to 3. Now, I got that in stages, right? The distance from Q to this point here is 8. From Q to the corresponding point of the original one is 6. Then reduce that. 4 to 3. Now, don't make finding X complicated. Just if from here to here is 8 and that's 6, what's that got to be? And there we go. You okay on finding the scale factor this way? New over old. B is the original one. B prime is the new one, so B prime goes on top. All right? Any other questions? All right. In a coordinate plane, if the center of dilation is the origin, finding the coordinates of the new figure, of the dilated figure, is really simple. You simply multiply the x coordinate by the scale factor and the y coordinate by the scale factor. That's all you got to do. So here it is in function notation. You would write this down. When you're doing a dilation on the coordinate plane and the center of dilation is the origin, the ordered pair xy becomes the ordered pair kx, ky. In other words, if the scale factor is 4, if the original ordered pair is xy, the new ordered pair is 4x, 4y. If the scale factor is 2/3, the new ordered pair is 2/3 x, 2/3 y. So, in the example they have here, with the scale factor of 2 and the center of dilation being the origin, point P has coordinates 2, 3. So point P prime will have coordinates 2 times 2, 2 times 3. 2, 2 times 3. All you got to do is multiply each coordinate by the scale factor. Neat, huh? Number 7 on page 663. It says find the image of each polygon with the given vertices after a dilation centered at the origin with the given scale factor. Now, the directions I copied said find the image. The directions in the book say graph the image. So let's graph. So I'll give you a second to graph A, B, C, D. All right, let's figure out what our new coordinates are going to be. Since the scale factor is 2, for point A, I'll multiply each coordinate by 2. So what's the x coordinate of A prime? -2. The y coordinate? 8. For B prime, the x coordinate and the y coordinate? for C prime, the x coordinate, y coordinate, D prime, -4, 4. All right, so that's the key, because if you can get the coordinates, you can put them on a graph. So let's graph it. -2, 1, 2, 8, +4, 8, 6, 4, and then -4. Okay, any questions? All right, we can do this, right? All right, let's take a look at number 8. This time, the scale factor is a fraction. And I don't expect you to be afraid of multiplying by a fraction. All right? Let's get the coordinates of J prime. So, the scale factor is 3 to 4. So for J prime, I need to multiply -2 times 3 to 4, don't I? All right, that's like a -2 over 1. So it's a negative what? Or as a fraction, 6/4, which reduces to 3/2. So either put 3/2 or put 1.5 or put 1.5. I guess I don't have a problem with 1.5. All right, to get the y coordinate of J prime, what's 0 times 3/4? 0. All right, then we move to K prime. Now, if -2 times 3/4 is -1.5, +2 times 3/4 will be +1.5. All right, what's 4 times 3/4? 3, isn't it, right? 4 over 1 times 3 over 4. 4's divide out, leaving you with 3, or 12 over 4, 3. What's 8 times 3/4? So that's a 6. 0 times 3/4 has to be 0 again. And we've done 2 times 3/4. That'll be 1.5. What's -4 times 3/4? -3. Is anybody surprised that the new figure is smaller than the original figure? You shouldn't be. The scale factor was between 0 and 1, wasn't it? So it's got to be a reduction. And it was. All right, this is wrapping up Unit 9 for us. So we're going to have a quiz over learning targets 8 through 11. But what I'm afraid might get you is to do the composition of transformations and some, not really with symmetry, but also with some dilations maybe. And definitely with the composition of transformations. You need to remember the things that we did with reflections and rotations. Remember the rules we had for reflecting in the y-axis and reflecting in the x-axis and reflecting in the line y equals x? You're going to still need to know those, because doing a composition of transformations, if your reflection is in the line y equals x and you don't remember how to do the reflection in the line y equals x, you won't be able to do the composition of transformations. Same thing with rotations. Remember how we learned the rule for rotating 90 degrees, 180 degrees, 270 degrees in a coordinate plane. You still got to remember those. Okay? So if you've forgotten those, that's something you might want to refresh your memory about before we get serious about studying for this next quiz. Okay? And here's what I need for you to do from this section. On page 663, do 2, 3, 5 through 8, 15 through 18, 21 through 26, and 42 through 50.